So for this video, this is going to be the creme de la creme, the cream on the top here. This video is a big one. This one has, I just stole this from the end of the book, and it has what mass, what grams, how many grams of this can be produced from 50 grams of iron. So this problem is going to have basically everything we've learned so far in this chapter. We're going to have to balance this equation because it is not balanced. On the exam, I will say that you do have an unbalanced equation. So we're going to have to balance it. Then we're going to have to turn it into mole, and then mole to mole and mole to gram, or mole to mole and mole to gram. So we're going to have to do all of it. Pack a lunch. So first off, we're going to balance this bad boy. Looks like there's a 3 on the Fe here, so we could put a 3 here. And then there's 2 oxygens here, and there's 4 here. So we just need to put a 2 here. So we did one thing right, we're balanced, and then you guys know me, I like to put the numbers down here. So I need to know how many grams here if I have 50 grams of this. So we're going from here to here. So I call them my mole hats. So this is, I can't compare the grams to grams, I can only compare moles to moles. So what do I have to do? Turn this into mole, and then compare 3 moles to 1 mole, and then 1 mole to grams. So let's talk about it. We can even write a plan here. I'm going to have to turn grams of Fe to moles of Fe, and then I'm going to have to compare moles of Fe to moles of Fe3O4, and then I'm going to have to turn it into grams of Fe3O4. So we're going to have to bust our calculator out. So let's start with what you're given. So 50 grams of Fe, of iron, right? Put it over 1. I use a line, but apparently it's just understanding easily if I put parentheses, so a lot of people prefer the parentheses. So what's the molar mass of Fe, of iron? So I'm going to pull up a periodic table because I did not think ahead and have one pulled out. Let's get the molar mass of iron. I believe it's somewhere around 55.845. So I need to turn this into moles. So mole of Fe is my desired. 1 mole of Fe weighs how much? 55.845 grams. Right? So now my current unit is moles of Fe because grams of Fe are going to cancel out. Now my next thing that I'm going to do is convert moles of Fe into what? Moles of iron oxide. How do I do that? So I'm going to say, what's the mole to mole ratio? 3 moles of iron will give me 3 moles of this iron oxide, or sorry, 1 mole of this iron oxide compound. 3 moles of Fe for every 1 mole of this iron oxide compound. So the iron oxide compound is my desired unit. I'll put that on top. So 1 mole of Fe3O4 for every 3 moles of Fe. So you see how we are now in this stage of the jump. Now we have one last step. It did not ask for moles of iron oxide, it asked for grams of it. So what I'm going to have to do now is turn it into grams. So how do I do that? How do I go from moles to grams? The molar mass. So I'm going to do that here on the side. Fe3O4. I know that Fe, I have 3 of them, and they each weigh how much? 55.845. And then how many oxygens I have are 4, and they weigh 15.999. So I'm going to do a little math. Alright, so when you multiply these out and you add them, you get 231.53. And remember, where does this number come from? The periodic table. So what are the units? Gram per mole. Remember? These are the units of gram per mole. So this many grams for every 1 mole. So 1 mole of it, and I don't have enough room to, well, I can. Fe3O4. 1 mole of Fe3O4 weighs how much? 231.53 grams. So how do I figure this whole mess out? So, and then moles cancel, moles of Fe, so this is my final step. So, how do I figure this out? I multiply 50 times 231, 50 times 231.53. I divide that by 55.845 and 3, so I get 69.09. So, to recap, let's recap. Where did I get this number from? This is our given. Where did I get this number from? This is the molar mass, so periodic table. Where did I get this number from? This is the molar ratio, the mole to mole ratio. Running out of room here, aren't I? And where did I get this number from? Again, the periodic table, right? So this is as hard as it possibly can be because we're doing the whole thing. We're going from grams to moles, moles to moles, moles to grams. I just uploaded a video where they just wanted us to go from moles to moles. That's just one step, and all we need to use is the mole to mole ratio. Here, they're having us go from grams. Now express it in terms of moles. Now compare how many moles there are. Now compare how many grams there are. So it's we have like a longer track to do, but it's not much more. It's doable. It's definitely doable. So I actually think I may have calculated something wrong. Let me double check. No, I did it right. I did it right. All right. So this is the answer. So please let me know if you guys have any more questions. So I do hope that this helped. We can do more problems later, more practice problems. But remember, this is as hard as it's going to get. This is the longest that it could possibly be. So this is definitely the biggest stoichiometry problem. Good luck, guys.